Okay, so in this one, they're asking us to find the ninth term here. So what is the first step do you guys think we would do here? What is our first step that we'd do? So this is the sequence. Skylar? Okay, so yeah, find the common ratio, or the R. And so how would we find the common ratio of the R? How do we find the common ratio of the R? Great.
Divide A2 by A1.
Divide A2 by A1. So we have negative 3/8 divided by 3/4. Okay, so again, if you're daunted by the fact that there are a lot of fractions here, what I would do is I would just rewrite this as negative 3/8 divided by 3/4. And then I would go ahead and rewrite this as the reciprocal, multiplying by the reciprocal, negative 3/8 times 4 divided by 3. So you can see here that just by transforming it, you can see it's so much easier to calculate without a calculator. Then you can see here, this is 4 times 2, so the 4's cancel out, the 3's cancel out, and we get negative 1/2. We get negative 1/2. So now that we have our common ratio, we can plug this into our formula here. We have A of n is equal to A1 R n minus 1. So the first thing we need to fill out here is, what is our n value? What is our n value? Does anyone remember? What term are we trying to solve for here? What term are we trying to solve for? Great?
The ninth.
The ninth. So what is n equal to?
9.
Right, 9. So here we could just say A, and again, this is A to the ninth, is equal to, does anyone remember, what is A1? What is A1 equal to? Gray?
Isn't it negative 3/8? Or, yeah, no, 3/4.
Right, 3/4, or the first term. So we write the first term right here. And then what is our R equal to here? What is our R equal to? Josefina? Right, negative 1/2. We just solved for it, negative 1/2. And then what is our n again? What is our n again? Right, it's 9, so then we just write 9 minus 1. We could plug this whole thing into our calculator. We get, let's see, 3, actually I'm going to write this on calculator, 3 divided by 4 times negative 1/2 to the 9 minus 1 power. And I get this huge decimal here. And an easy way to convert this so that it's a nice answer, you don't have to round it, is to go ahead and you can see on the first column, third row, you can just see this button called Math. If you press Math, it allows you to convert something into a fraction. You can just press Enter. And what it's going to do is it's going to convert your answer into a fraction. You just press Enter, and it's a nice fraction for us. 3 divided by 1024. So our answer is 3 divided by 1024. That's our answer. Does anyone need more time on the first problem? Okay, if not, I'm going to go ahead and move this up. So we have our second problem here. Okay, does anyone remember, what is our first step here? What is our first step here? What is our first step here? Gray?
Find the common ratio.
Find the common ratio. And what are we going to do?
Divide A2 by
A2 by A1. Okay, and that would be?
0.01 divided by 0.00.
Right, 0.01 divided by 0.001, which is equal to, I believe, 10. And then, so our common ratio, or R, is equal to 10. And then what can we do next? Does anyone know what is our next step here? What is our next step? Kiara?
Put into the equation a n equals a1r to the n minus 1 power.
Okay, and then could you tell me what my values are here? How do I write this?
For n, it would be would it be how much are you get n from?
Okay, so for this one, I did initially write this in your notes, but it was to solve for your nth term. So because we're solving for our nth term, then n would be equal to 9. Okay. So if it says solve for the nth term, then your n would be equal to 9. If it says solve for the 20th term, then n would be equal to 20. Okay. So in this case, a of 9 is equal to, and what's our a1, Kiara?
0.001.
0.001. What's our r?
The r is 10.
10. And what's our n again?
9.
Right, so 9 minus 1. So we just put this in our calculator. You can see here that this would be 0.001 times 10 to the 9 minus 1. And there we go. We get 100,000 as our answer. And you would just go ahead and write this 100,000 as our answer here. Okay, does anyone have any questions on this one? Okay, I'm going to show you one more example. I'm going to let you work, and then there's going to be one last part of the notes. So one last part right here, which is just so you can do the front and the back, and then you could finally do the same. So this last problem is a little different. It asks us to find, let's say it tells us to find the 10th term of a geoseries. So it might say something like this: find the 10th term of the geometric series given a of 5 is equal to 96 and a of 7 is equal to 384. So given that the geometric series where a5 is equal to 96 and a7 is equal to 384, solve for the 10th term. Okay, so in this case, you might be thinking, wow, that is pretty difficult. So the first thing we want to do is we also want to find the common ratio. And what you can see is that we know that a7 is equal to a of 5, right? We know that it's equal to a of 5 if we times by the common ratio, right? We know that they're separated by however many spaces a of 7 and a of 5 is separated by, which is 7 minus 5. So you can see here that, again, if we think about this practically, we know that to get from R, or the 5th term, to the 7th term, they're separated by 2 common ratios, right? You multiply by once, you get a6, and then from a6 to a7, you would multiply by another common ratio to get a of 7. Okay. So to solve for this, we just plug the numbers in, right? We know a of 7 is equal to 384. We know a of 5 is equal to 96. We don't know what the common ratio is, but we know that it's 7 minus 5, so we know it's r squared. The next thing we would do is now we want to solve for the common ratio, so we want to divide both sides by 96. Divide both sides by 96, and we get r squared is equal to 384 divided by 96, which I believe is 4, and we get r squared is equal to 4. Okay, so again, what we want to do is we want to plug this in. So the last part here is you want to solve for r. But you can see here this is r squared, so we want to square root both sides. If we square root both sides, we know r is not only equal to 2, but it is equal to plus or minus 2. So that's where the fun begins. Again, r is equal to plus or minus 2 because we square root both sides. Okay, so now our next step is to solve for a of 1. Our next step is to solve for a of 1. So we know that our basic formula is a of n is equal to a1 r to the n minus 1 power. You know, this is our basic formula. What's one of the terms that we know? What's one of the terms that we actually know? Josefina? We know r, and what's one of the a's that we know? Like which term? Do we know a1? Not quite yet, but we know another, we actually know two of them. What are the two that we know? Saad, are you raising your hand or stretching? Oh, Gray?
No, n is equal to 10.
We know n is equal to 10, sure. But what about one of the other terms? Because we don't know what a1 is, so we can't quite solve for it yet. What other two terms were given to us? What other two terms were given to us? Gray?
A5 and A7.
Right, A5 and A7. So we know the end results. We know the R. So let's plug in what we know. Again, math is all about figuring out what you have and then solving backwards to get to the beginning. So in this case, we know A5. So I know A5 is equal to A1 R, and we can do 5 minus 1. So that's the first thing we know is we know A of 5. We can then plug in A of 5, and we can plug in R. And here you can see that we have two values of R, so we're going to have to plug in two formulas. So here we have 2 to the 4th power, or we have 96 is equal to A1 negative 2 to the 4th power. And again, the reason I have two different formulas is because I have two different values of R. Okay? So again, the reason I have two different formulas here is because I have two different values of R. The next thing I would do is I would solve, so I get 96 is equal to, so 2 to the 4th power is equal to 16, so 16 times a to the 1st power, or I have 96, which is equal to also 16 to the a1, and then I just want to solve for a of 1, so divide by 16 on both sides, divide by 16 on both sides, and I get a1 is equal to 6. So either way, I get the same answer that a1 is equal to 6. So either way, I get a1 is equal to 6. Does anyone have any questions at this point? So just to recap, the first thing that we did is we solved for r by solving this way, where we plug in the different values. You can see that for n, we plugged in our farthest value, and then we subtracted it by our closest one. Then we divided both sides by a of 5, or 96, to isolate the r squared. We then square rooted both sides to solve for r. After that, we solve for a of 1, and we solve for two versions of our formula because r had two values. So we have two equations. We have, so here we have, if we look at our equation now, we know that a10 is equal to a1 r to the 10 minus 1, right? So we know that we have this equation right here, right? We do, however, have two different values of r. So we first have a10, which is equal to 6, which is a1, which we solve for, to the 2, 10 minus 1. Or we have a10, which is equal to 6 times negative 2 to the 10 minus 1. Okay. Does everyone remember that we have two different equations because we have two different versions of r? So again, we have two different equations because we have two different versions of r. We solved for a1, and we saw that a1 was actually the same for both equations, and that's why both of them look almost identical. You could just next put this into your calculator, so you could just do 6 times 2. So for the first one, you would just do 6 times 2 to the 10 minus 1, and I get 3072. And you could just do the same thing for your other one, except this time you actually want to be a little more careful here. You want to insert some parentheses, and you would get this. So you plug it in, and you can see that the difference here would be negative 3072. So that would be the two different answers.